chemistry, to be successful, it is vitally important to understand how to read a periodic table. There are thousands of conclusions and details that can be drawn from the table. However, there are a few main points that are needed in order to begin to learn chemistry. First, let's remind ourselves what each box means. Every periodic table has 109 boxes, which each represent a different substance. These substances we call elements, or rather a material that cannot be chemically interconverted or broken down into any simpler substance. Each element is distinguished by its own name, symbol, atomic number, and mass. But more on that later. The periodic table is organized into rows and columns. The rows we call periods, they go across, and the columns we call groups, and they go down. Each group and period have their own set of properties. For example, group 18, which consists of helium, neon, argon, krypton, xenon, and radon, we call the noble gases. They are extremely inert and typically don't bond with any other element. They also have the same number of valence electrons, or rather, the same number of electrons that spin around the outermost part of each atom of that specific element. And in this case, that number is 8, except for helium. In addition to groups and periods, the periodic table is also split into sections. The metals, which are consistent of the alkali earth metals and the alkali metals, and the transition metals, which are right here. These are the transitions. Metalloids, which follow along this staircase right here, and the nonmetals, which are right here. Each of these various sections has their own properties and are extremely important when understanding how various elements interact with each other. If we specifically look at one element box, let's take a look at helium. There's a lot of information we can pull from this one portion of the table. The first thing we can look at in the box is its symbol, He. Every element has its own symbol, either 2 or 1 letter. These are typically derived from either the person who discovered the element, where it was discovered, or the language it was taken from. For example, gold has the element symbol Au, which is derived from the Latin word aurum. The next number we see in the box of helium is 2. This is the atomic number. This number tells us the number of protons in the nucleus of the atom. Protons are a subatomic particle located in what we call the nucleus, or the center of the atom. This number will never change, unlike the number of neutrons or electrons. Protons carry a positive charge, and in order for the element to be neutral in charge, we have electrons carrying a negative charge around the outside of the nucleus in what we call an electron cloud. So in the case of helium, we know there are 2 protons based on the atomic number. And if we are not told differently, we can assume the atom is neutral. Therefore, we would have 2 electrons to balance out the positives. Occasionally, we can have an atom with either more or less electrons than the neutral form of that element, and in that case, we call it an ion. In addition to protons and electrons, we have another subatomic particle located in the nucleus called neutrons. Neutrons are neutral in charge and contribute to the overall weight of the atom. Below the element symbol, we see another number. This is the mass of the atom. Both the protons and neutrons contribute to this mass. Electrons contribute in a very minuscule amount. In helium, we see the mass as 4.003. This is 2 protons, 2 neutrons. Typically, the number of neutrons equals the number of protons, except for special cases called isotopes, plus a little extra from electrons. And with that, we get 4.003. If, for example, we wanted to know the mass of a molecule of table salt, NaCl, we could add up the masses given on the periodic table, Na being 22.989 and Cl being 35.45. So the mass of one molecule of table salt, or NaCl, is 64 0.439. Overall, the periodic table can tell us a lot about the reactions of various elements, the size of molecules, and their abilities to bond with others, and even the likelihood of finding them in nature. The periodic table is a beautiful tool that, when read correctly, can help any scientist further their studies.